So in this video, we're going to continue with the polynomial and rational functions. So we did the first part of the video where we talk about the limit of polynomial and rational functions, and we look at the first part using limit to solve polynomial and rational functions. So in this particular video, we'll continue with the previous video that we did. So in this particular video, as I said, we are going to talk about evaluating limits by multiplying a conjugate. So let's look at this example. So we are going to evaluate lim of the root of x plus 2 minus 1 on x plus 1 as x approaches negative 1. So in this particular problem, you can see that the root of x plus 2 minus 1 on x plus 1 has the form of 0 over 0, right? So it has 0 over 0 at a negative 1. So we are going to begin by multiplying the root of x plus 2 plus 1, which is the conjugate of x plus 2 minus 1 on the numerator and the denominator. Okay, so if you should do that, we are going to get the lim of x plus 2 minus 1 on x plus 1 multiplying x plus 2 plus 1 on the root of x plus 2 then plus 1 outside. Okay, now when we multiply out the numerator, then we don't multiply the denominator because we are not hoping that x plus 1 in the denominator cancel out at the end. Okay, so we are just going to multiply the numerator part. We are not going to multiply the denominator part because, again, we are hoping that the x plus 1 in the denominator do not cancel out at the end. Okay, so when we should do that, we should get lim of, when we multiply this, we are going to get lim of x plus 1 on, so this x as approaches negative 1, then we have into bracket x plus 1 open bracket multiplying the root of x plus 2 plus 1. Okay, so this is where we are going to have as x approaches negative 1. All right, now then the last step, which is step 3, is to cancel out. Okay, so when we cancel out, we should get lim of, so this x plus 1 will cancel the numerator, which is x plus 1. Okay, then we have lim of x approaches negative 1, which is 1. Okay, so when we cancel, it should be giving us 1. Then the root of x plus 2 plus 1. All right, so we are gonna get this. Now here we can go ahead and substitute the negative 1 into wherever we see x. Okay, so when we do it, we should get 1 on the root of 1 plus 2 then plus 1 here. Then we should get 1 on the root of 3 plus 1. Okay, so sorry, this one should be negative 1. This should be negative 1. So if it is negative 1, then it was plus 2. So let me just go back and do that kind of correction here. Okay, so negative 1, which will give us 1. So we have the root of 1. So let me just cancel this. There we have 1 on root 1 plus 1. And root 1 is just 1. So we have 1 plus 1, which will give us 1 on 2. Okay, so this is the answer for this type of question. Okay, so you can pause the video and try to do this on your own. Evaluate lim of roots x minus 1 minus 2 on x minus 5 as x approaches 5. You can do that. Now let's continue. Let's go to our next example. In our next example, we are going to look at a problem that involves limit by simplifying a complex fraction. Okay, so let's look at this example. So in this example, we have lim 1 on x plus 1 minus 1 on 2 divided by x minus 1 as x approaches 1. Okay, so the first step, let's look at the first step. So step 1. So you can see that 1 on x plus 1 minus 1 on 2 on x minus 1 has the form of 0 on 0 at 1. Okay, so when you put the 1 into this kind of function, you are going to get 0 on 0. So we need to simplify the algebraic fraction by multiplying. So we have to simplify this function by multiplying by 2 into bracket x plus 1 divided by 2 on x plus 1. Okay, and now when we do this, we should get 1 on x plus 1 minus 1 on 2 on x minus 1, which is a lim as x approaches 1, which will be equal to 1 on x plus 1 minus 1 on 2 on x minus 1 divided by, multiply by 2 multiplying x plus 1 on 2 multiplying x plus 1. Okay, so this is what we get. So which is lim, you bring your lim as x approaches 1. Okay, and now that's step 2. So what we are going to do in the step 2 is to multiply through the numerator. Do not multiply the denominator, as I said, as we did before. Okay, we do not want to multiply the denominator because we want to be able to cancel out the factors. Okay, we want to be able to cancel out the factor, which is step 3. Okay, so here we just multiply the numerator and leave the denominator as it is. Okay, so when we multiply the numerator, we should be getting lim of 2 minus x plus 1 on 2 multiplying x minus 1 multiplying x plus 1. Okay, as x approaches 1. Okay, then the step 3, we are just gonna simplify the numerator. Okay, so if we simplify the numerator, we should get minus into bracket x plus 1, so which is 2 there. Okay, and then we will have x we have 2 multiplying x minus 1. I'm just rewriting it again. Then I'll write it here because we have 2 minus plus 1. Okay, so it's simply like 2 so the multiplication just this minus sign right here just go through. Okay, so minus x minus 1. All right, then we should be having, so that's the top one that I just did right here. So that's just the top. So minus 2 minus 1 adding it to 2 there, so we should get in which is minus x plus 1 on 2 multiplying x minus 1 x plus 1. Okay, so now at step 4, so let's look at step 4. Now we have to factor out the minus 1 from the numerator, okay, which we have already done. Okay, then we cancel out the minus x right here. Okay, so let's just factor out the minus. So we will have minus 1 on 2x minus 1 x plus 1. Okay, then we cancel out the x minus 1. Okay, so we have this x minus 1 cancel x minus 1, then we get negative 1 on 2 multiplying x plus 1. Okay, now this is still lame as x approaches 1. Okay, so at this point we can just substitute the x value into the function, then we can find our value. So we have negative 1 on 2 multiplying 1 plus 1, then we have negative 1 on 2 multiplying 2, which is 4. So we have negative 1 on 4, which is very simple. So you can pause the video and try to do this on your own. Evaluate 1 on x plus 2 plus 1 on x plus 3 as x approaches negative 3. Okay. So let's look at another example. So in this example, we are going to look at a function that when we are evaluating the limits, the limit laws do not apply. Okay, so let's look at that kind of example. So we have example of lim of into bracket 1 on x plus 5 on x open bracket x minus 5, then close bracket as x approaches 0. Now if you look at this function closely, you can see that both 1 on x and the 5 on x multiplying the x minus 5 fails to have a limit at 0. So since neither of the two functions has a limit at 0, we cannot apply the sum law for the limit. So we must use a different strategy. So in this kind of example here, we will find the limit by performing addition and then applying one of the previous strategies that we talk about. So let's look at that. Okay, now if you look at it, you can see that 1 on x plus 5 on x minus 5, which that multiplying x here will be equal to x minus 5 plus 5 on x multiplying x minus 5. And then when we simplify it, we should be getting x on x multiplying x minus 5. Okay, now so with this we can see that the lim of 1 on x plus 5 on x minus x multiplying x minus 5 will be equal to the lim of, so this as x approaches 0, as x approaches 0 will be equal to x on x multiplying x minus 5. Okay, and when we simplify it, we should be getting the lim as x approaches 0, 1 on x minus 5. Okay, then we cannot put 0. When we put 0, substitute the 0 where the x is, we should be getting negative 1 on 5. Okay, so this is very, very simple. This is very, very simple to do. Now you can try this on your own. Let's look at this example. You can try it on your own. We have the lim of as x approaches 3, open bracket 1 on x minus 3 minus 4 on x squared minus 2x minus 3. Just try this on your own. Now let's now revisit one side limit. Okay, so simple modifications in the limit laws allow us to apply to one side limit. Okay, so example is example is to apply the limit laws to a limit of the form of lim of h of x as x approaches a. We require the function of h of x to be defined over an open interval of the form of a c. Okay, so I know this is kind of complicated. Let's look at some example to be more open about this kind of strategy that I'm talking about here. Okay, so with this example, we have the lim of the root of x minus 3 as x approaches 3. So with this one, we are going to look at some graph right here. Okay, so let's say we have this graph where we have the y, we have the x, we have 1, we have 2, we have 3, we have 1, we have 2, we have 3, we have 4. Okay, goes and on. Now let's plot this kind of function, which is f of x equal to root of x minus 3. Okay, now when we plot this function, we can see that it is 3 here, so 3, then it goes straight like that, right? It goes straight like that. It goes straight from here. Okay, so this graph just showed this function that we just talked about. Okay, so the function which is f of x equal to the root of x minus 3 is defined over the interval of 3 comma plus infinity, so positive infinity, okay, or positive finite. Okay, so this one will be a close one, so close. Okay, so since this function is not defined the left of 3, we cannot apply the limit laws to compute the lim of the root of x minus 3 as x approaches 3. Okay, so in fact, since f of x, which is equal to the root of x minus 3, is undefined to the left of 3, the lim of root of x minus 3 as x approaches 3 does not exist. Okay, does not exist. Now let's look at this one too. Let's look at this one. Now if you have a function of f of x so f of x being equal to 4x minus 3, then you have open bracket x minus 3, then you close. Now if x is less than 2, and this one if x is greater or equal to 2. Okay, so we are going to evaluate the following limits, okay, with this condition. So a, if lim of f of x as x approaches 2, okay, and b, lim of f of x, so this minus, okay, this minus and this positive, of x as x approaches 2. Then the last one is c, lim of f of x if x approaches 2. Okay, so let's look at the solution for each. Now first of all, before we do that, let's plot this function. Let's plot the function in this form. Okay, so let me just draw my graph. This is a rough graph. So I have my x, I have my y. All right, so I have 1, then 2, 2, -1. I have my 1, 2, 3, 4, 5. So 5, 4, 3, 2, 1. Okay, then I have my 1, 2, 3, 4, 5. So 5, 4, 3, 2, 1. Okay, now let's plot the first one. So the first one is gonna pass through like a straight line going to this direction. Let me use a different color as blue right here. So it will pass here, ends here, which is open. Then the other one I'll use green here, and that also pass through the 3. Okay, so 3 comes down, then it touches the 3, and it goes up. Okay, so this is a rough graph, that's why you don't see it well, but it just goes up like that. Okay, so this f of x. Okay, so that's the function. Now let's look at the first question, which is a. Okay, so a, so we have f of x equal to 4x minus 3. Now for this one, for all x in negative finite, I'm just calling this one negative finite, then comma 2. Now we are going to replace the f of x in the limit with 4x minus 3 and apply the limit loss. Okay, so that's what we are going to do right here. So if we have this, we are going to have the lim of then the negative f of x as x approaches 2. Okay, then we have lim of negative, let's replace it. So we get, when we place that, we get 4x minus 3, all right, as x approaches 2. Okay, now let's input the x into the function. Okay, so when we input that, we should get 5. When we input that, we should get 5, because we'll get 8 then minus 3, so 5. Okay, now b, so f of x equal to x minus 2 minus 3 squared. Okay, now for all x in 2 comma plus finite. Okay, let's replace the f of x in the limit of x minus 3 squared. Okay, then we apply the limit loss. Okay, so when we replace that, we should get limit of x approaches 2 plus then x minus 3. Then when we put the 2 inside, we should get 1. Okay, and the last one, c. Now since the lim of f of x equal to 5 as x approaches 2, and the lim of f of x equal to 1, we can conclude that the f of x, which is lim as x approaches 2, does not exist for the c. Okay, does not exist for the c. So you can try this on your own. So just graph f of x equal to negative x minus 2 if x is less than negative 1, and 2 if x is equal to negative 1, and the last one is s cubed if x is greater than negative 1. Okay, now do it, and we will meet in our next video. Thank you for watching.